In this particular example, we've been asked to find the maxima and minima for the irrational function g of x equals x to the 2/5. We start by taking the derivative, g prime of x, which is equal to 2/5 x raised to the negative 3/5. We're going to set that derivative equal to 0, and then I've written the derivative in a slightly different form. Rather than saying 2/5 x to the negative 3/5, I'm going to say that it's a 2 divided by 5 x to the 3/5. It's clear when you have the derivative in this form that there is no value of x that will set g prime of x equal to 0. However, g prime of x is undefined at x equals 0, which means g prime of x does not exist at x equals 0. So we have the x coordinate for one of our critical points, because remember, a critical point can occur not only when g prime of x is equal to 0, but when g prime of x does not exist, which is the case here. So I've got my x coordinate. I need to find my corresponding y coordinate. So I use my function g of x. G of 0 is going to be equal to 0 to the 2/5. So g of 0 is equal to 0. So I have a critical point with the coordinates 0, 0. The next thing I have to do is determine whether that represents an absolute minimum, an absolute maximum, a local minimum, or a local maximum. So I'm just going to do a sketch of the curve. Some of you may be able to figure out what the function g of x would look like without using your graphics calculator, but I think most of you will need to rely on it. So when you type it in and graph it, you get a curve much similar to the one I've got up here in the upper right hand portion of the screen. Using the green marker, I've labeled our critical point 0, 0, and when I do so, it becomes very clear that this critical point actually represents an absolute minimum for our function.